Assalamu alaikum everyone. Hope you're all fine. Welcome back to my channel. In today's video, I'll be doing the Computer Science 9618 and paper 3 Advanced Theory. And this paper is October number 2025 and the variant is 32. All right. So let's start. In the first question, the composite data type car is defined in pseudocode as, so this is the type uh, definition of this type car, and it is defined in these. So these are the variables in this type, record type. So this is the record type. So in this record type, um, write the pseudocode statement to set up a variable for one record of the composite type car. So we need to use this variable, this type, to declare a variable of one record of the composite data type. So we need to, so what we will write over here, we'll write declare a variable will be created, like it can be the car one, and this will be of type. You can see that this type is written here. So this type will write here. All right. So this is how we do this question. And the second part, write the pseudocode statement to assign the following values to the variable set up in the part A. So here the variable which we have just declared. So this variable, now we need to assign the values to it. So how these values are going to be. So blue to a color and the state to into a stock. So you can see that color is here is one of the data of this type car, and the other is the date. So we have the other is the in stock, into the stock. So we will use color and into the stock. So the variable is car one. So car one dot. So the variable data is also mentioned here. So COLOUR, and it will be assigned blue. And the other is car one dot into stock, and the value given is 21 10 2025. So this is the value that is given to it. All right. So this is how this part is done. The data type for body style is changed to an enumerated type body. So body style, you can see this part. Now they're talking about this. The data type of the body style is changed from uh, this string to the type enumerated. Write the pseudocode statement for the type declaration of body to hold the names. So these names. So what we will write, you can see that the type will be changed here. So we'll write type, and this is body type. Body is equal to, now we are going to write all the values in it, like the convertible, the hatchback, saloon, write it the next line, SUV. Okay. So this is how, now one mark will be given. You will get one mark is for sorry, one mark is for this, and one mark is for this. All right. Write the new pseudocode statement required to update the declaration of body style in the definition of the car. Required to update the declaration. So this new update the declaration of the body style in the definition of the car. Now in this part, what we have to do now, we just need to declaration of the body style. So we need to write declare body style. Now this is going to be of type body. All right. So we declare it like this because this is another type which we have just created, and then the body style is declared from this variable. All right. Question number 2. Now in the second part, The numbers are stored in a computer system using the binary floating representation, 10 bits for the mantissa, 6 bits for the exponent, and 2's complement for the mantissa and the exponent. Calculate the Denry value of the given normalized binary floating point. Show your working. So here you need to show the working. So need to convert this exponent, which is 1, 2, 4, 8. So basically 8 and 2 and 10 and 1, 11. So 2 raised to power. This is the exponent part. Okay. And the number is now 0 and it is an invisible dot 1, 1, 1, 1, 0, 0, 1, 0, 1. So this is the mantissa part. Now this exponent is to be applied. So what will happen? Now on this dot is going to, because whenever this, from where this dot came, it is actually an invisible. This is the rule that whenever the mantissa side, there is an invisible dot in the first 2 bit on the extreme left side. All right. There is an invisible dot between. So we'll consider it from there, and 11 is going to be applied. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we need to have more zeros, and then the dot will come over here, and then so another zeros. So the number will become 1, 1, 1, 1. So 4, 1, 0, 0, 1, 0, 1, 0, 0 dot 0. You can call it like this. Okay. What is the impact? Now when it is applied, number will become, now we will just see, this is 1, 2, 4, 8, 16, 32, 64, 128, 256, and then 5, 12, and then 1024. So we need to add these numbers under which we have 1. So 1024 plus 512 plus 256 plus 128 plus 16 and plus 4. All right. So all these numbers are going to be added. And when we add them, what is the answer? So if we add them, I did this calculation. So the answer is 1940. All right. 1940. So this is the answer. So dot 1940 dot 0. So we can write the Denry value is, this is the answer. All right. Okay. Now in the next part, B part, calculate the normalized binary floating point representation of plus 26 dot. So we need to calculate this. Now the number is plus 26 dot 6875. Okay. Now in this number 26.6875. Now we need to write the, on this part 26 is 1, 2, 4, 8, 16. So 16 and 8 is 24. So 1 and 1, this is 24 and this is 26. So 11010. Okay. And now 6875. Now you know that on the other side we have 0 0.5, 0.25, point. Now we'll keep on halving it. This is 0.125. You can have the scale in your rough area so that you can keep using it. So when we further divide this 0.125, so this become 0.0625, and we further divide it. So this is 0.03125. I think it will be enough to calculate 68. So we need for 68.68. So 0.5, we can have 0.5, and then we can have 0.125, and then we can have 0.0. We need to create 6, and then we need to create 0.625. So what it will become? 6875. All right. So we need to put 1 under this, and then 1 under this, and 1 under this. So this is enough. So you can see the number became, the number is 1101.1011. This is the number. Now we need to take this dot to its right place. So 1, 2, 3, 4, 5. The dot comes here. So 5, so it means it become 0.1101010011 into 2 raised to power 5. So this is 1, 2, 3, 4, 5. Okay. Now 5 become exponent is 1, 2, 4. 4 and 1 is 5. So put 0 here. And the other, this is going to be stored from this side. So 0, 1, 1, 0, 1, 0, 1, 0, 1, 1. So basically 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. So 0, 1, 1, 0, 1, 0, 1, 1, 0, 1, and 0, 1, 0, 1, 1. So this is the answer. All right. So this is how we solve it. Now the third part, third question. In the third question, HTTP and IMAP are examples of protocol used in the application layer of the TCP/IP protocol suite. Now you need to clearly, first of all, understand the question. HTTP and IMAP are the example of protocol in the application layer, and it's a part of the TCP/IP suite. State the purpose of the HTTP and IMAP protocol. Simple. HTTP is responsible for the communication between the browser and the web page. Okay? So HTTP basically it sends and receive the what web pages between web browser and web server. So basically this is the protocol which is responsible for the communication or the transfer of the pages between server and the browser. And IMAP, it is an instant uh, messaging. It is the instant messaging protocol. Okay, so the IMAP is the protocol that allows users to access their emails without removing messages. So without removing messages from the mail servers. Basically, the alternate to the IMAP is the POP3, and in the POP3, when the user log into its email account, all the waiting emails received on the web server, they are all pulled into the user machine. So the data is actually then copied from and moved from the web server's email server to the user's machine. So they are actually removed on the mail server. So this in the IMAP, this is the more advanced form of the protocol associated with the pull protocol, and they keep on sending the emails and in the user's device without removing the messages from the mail server. All right. Now describe how files are shared using the BitTorrent protocol. Now the BitTorrent protocol is the example of BitTorrent protocol is the example of the peer-to-peer network. Okay. So the BitTorrent protocol, how files are shared between the using the BitTorrent protocol. And as I keep on advising my students that please do understand and do read the command words and understand the purpose and the meaning of it, because your answer is totally based on the command word in the question. All right. So describe means you are going to write the key points in the process of the thing that is mentioned in that question. Like here it is BitTorrent. So basically, so how will we answer it? How the files are shared using the BitTorrent protocol. First of all, files are shared over a peer-to-peer network. Number one. So basically, this is the peer-to-peer network in which the BitTorrent is used. BitTorrent protocol is used. Okay. Then a small file torrent. Okay. A small file torrent is created by a peer. A small file is created by a peer. A small file torrent is created by a peer. So 2 points. Then the so this torrent is basically a descriptor. Okay, this torrent file. This torrent contains it contains this torrent contains the metadata about the file. Okay, to be shared. So basically इसके अंदर BitTorrent के अंदर what is there, this BitTorrent protocol, this file which is the small file, it has the description about the file to be shared. Okay, the file is broken into small pieces and then equal size small pieces. Okay, equal sized small pieces. The peers download these pieces. Okay, and also download the torrent, the descriptor. Okay, so although the four marks means you just need to write 4 points. If these you write these points, then the answer is enough. Identify one benefit of circuit switching and one benefit of packet switching. The benefit of circuit switching, you can see that the packets, no loss in the packet. All right, dedicated path is available, so whole bandwidth is provided. This is the benefit in the circuit switching. So the whole bandwidth is available for the packets to travel, and this increase the speed of the packets to reach the destination, and the packets, they are not lost. Okay, so these are the benefits. And the packet switching, uh, no need to tie up a communication line. No need to tie up a communication line. Okay, so the bandwidth can be used by the other packets as well. Okay, now the B part, identify two differences between circuit switching and the packet switching. The circuit switching requires a, a dedicated line to be available before the data transfer starts, while in the packet switching, just sends the packet, all right, straight away. It sends the packet strictly. So there is no arrangement of a dedicated path for it. Then another point, circuit switching. Um, Circuit switching uses the whole bandwidth for the transfer of data packets, while packet switching shares it, shares the bandwidth with other packets. Okay. Describe how interrupt handling is used in low level scheduling. Okay. The low level scheduler, the low level scheduling manages the handling of, basically इस क्वेश्चन में आपसे you are asked to write the technique of handling the interrupt at the low level scheduling. Okay, ये आपका process management का एक important aspect है, which is asked here. Process management, you know, is the different in the process management. The program which are on the hard drive, they are loaded into the RAM and then they are called as process. Process is a running program. So when they comes in the process, they wait for their turn, and they wait for their turn means they wait for the CPU time and the availability of the resources. And then there are different algorithms which are being used. So considering all these things in mind, and if once the low level scheduling, who is responsible to handle these running processes between uh, when their turns, the turn came. So at that time, if there is an interrupt, how it will be handled. So this is the context of the question. The low level scheduling manages the handling of interrupt. How it manages it based on, this is important, based on priority. All right. So it will look at the priority of that interrupt. Okay. So if the priority is higher, what is the, let's say if so, priority on priority. So to the ensure that the critical events are handled without any delay. So there is no delay in handling the top priority critical events. In process management, a process can be in one of three process states. I just mentioned this thing: running, ready, or blocked. Complete the table to identify one reason why a process could be in each of these states. Now, why this process is in the running state? It means the process is in the running state when the CPU time, the CPU time is allocated, and the process is under execution. So this will be the reason of running. The second is the ready. Here, the process is currently waiting for its turn to get CPU time slice so that it can run. So in the ready state, it is actually waiting. Okay. Now what is the block? The process under execution is now waiting for input and output operation to be completed. So it is IO bound. Okay. So then it is sent to the block state. All right. So these are three states. These are the three states. So when it enter the process enter, it first is in the ready state. This I'm drawing just for your understanding. And then from the ready, it comes to running. And from the running, it goes to blocked. And from the block, it again comes to the ready. Basically, it's like this. And from the running, it usually exit. So from here, it enters. Okay. Question number 6. The diagram shows a logic circuit. Complete the truth table of for the given logic circuit. Okay, now the question number 6, the diagram shows a logic circuit. Now we need to just complete it. How will we do this? You can see that first of all, the B is P means will invert the B. 0 is 1, 0 is 1, 1 is 0, 0, 1, 1, 0. So P is calculated. Then R is from B and C and XOR B and C, B and C, and it gives R. And you know in XOR, the 0, 0 is 0, 1, 1 is 0, and 0, 1 is 1, and 1, 0 is 1. All right. So when you have two similar, so B and C, so B and C is giving us R. So 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0, 0, 0 is 0, 0, 1 is 1, 1, 0 is 1, 1, 1 is 0. So R is calculated. Then is the Q. Q is from basically P and A, and XOR is used. P and A. XOR is used, and this gives us Q. So now again the same thing, P and Q. 0, 1 is 1, 0, 1 is 1, 0, 0 is 0, 0, 0 is 0, 1, 1 is 0, 1, 1 is 0, 1, 0 is 1, 1, 0 is 1. So we calculated Q as well. Now S is from Q, P, Q, P, and R. Okay. So let me make it more clear. Q, P, and R. And what is applied on it? Basically, it has, there is there is and says all the three one, then only we get one. So this is 0, this is 1, this is 0, 0, 0, 0. Only one place we get. Okay, now the last step. And what is the last step? We need to have S, we need to have P, and we need to have R. So we need valued S, P, and R. So these three will be used to calculate Z. And what is here? We have OR. So what we will do? So this is 1, 0, 0. So OR any one is 1. 1, 1, 1. So we have 1. So we have 1. So here we have 0. We have 1. So we have 1. So here we have 1 and 0. This is the answer. So we have 3, 0, 3, 1 and 0, 4, 1 and 0. So this is the correct answer. All right. Next part. Complete the K-map, Karanoff map for the Boolean expression. So now we need to complete it. How? We have this expression with us. All right. So we have this expression with us. Now let's start. A naught, B naught, C. So A naught is taken as 0. So whenever there is a naught or complement on any variable, so it is actually 0. So A naught, B naught, C is 0, 0, 1. So this is A and B, C. So A naught, 0, 0, 1. So here we will put 1. Okay. The second is 0, 1, 1. So this is the 0 and 1, 1. So the second is here 0, 1, 1. Third one is 1, 1, 0, 1. So 1, 0, 1. So this will come over here. And fourth one is 1, 1, 0. So 1, 1, 1, 1, 0. So actually it comes over here. All right. So all others, please do fill zeros in the leftover area. Some students, they made this mistake that they leave these cells without writing anything in it. So you must write. Okay. Now, filling this table gives you the 2 mark. You should be clear about it. Then draw loop around the appropriate groups. So groups, you already know that we have a group of 1, we have group of 2, we have group of 4, and we have the group of 6. Okay. So what we will do now, the group of 2 is this, group of 2 is this, and we also have group of 1. So we will have these groups. Write the Boolean expression from your answer to part as a simplified. Now we need to simplify it. First of all, we'll take this group, and this group we have, this is 0, 0, 1. So 0, 0, 1 is A naught, B naught, and C. And this is 0, 1, 1, A naught, B, and C. You can see that the complement cancels each other. So the common is A naught C. The one we write here is A naught dot C. So this dot is always there. It is actually the product. This is sum of product. Okay. So you can see here is sum of product. Okay. Now the second one, second combination. Draw this on the other side. The second combination is that this one, first of all, 0, 0, 1. So 0, 0, 1. And this one is 1, 0, 1. So basically 1, 0, 1. Okay. So here they both are cancelled. And this become the B naught C. And third point is that there's also 1 over here. So we'll not leave this unattended. So what we will do, we'll just write it because it is one member. So we cannot check out the common. So we just write it. So this is 1, 1, 0. So it is A naught, sorry, 1, 1, 0 is A, B, and C naught. So there is a dot in between. You can put this dot here. All right, so this is the answer. Done. Identify one other type of cryptography. One is the asymmetric, the other is symmetric. An organization hold two asymmetric encryption keys which they intend to use to receive to secure transmission. Explain how the organization make use of two keys to secure, how these two keys are used. Okay, so now you need to mention, first of all, the two keys used by the organization are public and private key. This is the first thing. The organization published the public key. All right, available to anyone who wants to send secure message. All right, this is the key strategy, that the organization will publish the public key to for the senders, and now the sender uses public key to encrypt the message and send to the organization. The organization uses private key to decrypt the secure message received. All right, this is how we solve this question. State the purpose of optimization. Optimization stage in the compilation of the program. You know the optimization. This is the compilation. Compilation of the program is done by the different stages, and one of the stage in the compilation is the optimization, in which we actually improve the codes which are written and the line of the codes, and avoiding any earlier task that is already being done and is not repeated, in order to decrease the machine code that will be finally calculated. So what is the impact of it? Minimize the minimize the program storage. Okay, so it will definitely decrease the program storage, and it will also minimize the CPU time. Basically, when the instructions they will decrease, definitely it will impact the CPU use. Minimize the memory use. Okay, so you can write any point from it. Convert the reverse Polish notation RPN back to its original infix. So convert the reverse Polish notation RPN back to its original form. So what we will do, we'll use the stack. So first A is pushed, B is pushed, and then minus. So this become A minus B. Then C is pushed, then plus So this becomes A minus B plus C. All right. Then C is pushed, then A is pushed, and then minus is pushed. This becomes what it will become. It will become A minus B plus C. So first minus is pushed, so it is actually C minus A. And what comes next? Then comes the star. So this becomes the uh, basically it is a star in between. So we can write here A minus B plus C multiply by C minus A. Okay. Then D is pressed. So it shows that there is a backslash, and then before then comes, we write here D comes and then minus. So basically it is divided by D. Okay. So this is how we do it. Now the RPM expression is this, and we have to solve it. So the same thing, we'll do it again. How? Uh, First, C is pressed. Now we just need to follow these steps. So it is not C. C is basically 9. So 9 is given. And next time is A, which is 3. So 3 came here. And then what is the sign? Divide sign. So 3 and 9 divided is 3. Okay. 3 comes here because the divisioning is applied. And then the next one is B. What is B? B is 16. So next time after 3 is the 16. And then B, after B we have D, which is 6. So 3, 16, and 6. So this is done. And then comes the minus sign. Minus means 16 minus 6. So this becomes 10. All right, so this is done. And then comes the multiply sign. So multiply means 10 into 3 is 30. This is done. And after 30, that B is added. 30, and what is the power of the value of the B is 16. And then plus sign is added. So this become 40. Sorry, B was 16, not 10. So this become 46. Okay. So the answer is 46. This is how the RPN question is done. Clear? Now the ninth question, deep learning is the one example of deep learning is the form of a machine learning. State one example where deep learning is used. Where the deep learning is used. So there are various things that you can write. The deep learning is the machine learning form of the machine learning. So it can be the language processing. Deep learning is the foreign language. State one example where deep learning is used. It is the natural language processing. This can be the natural language processing. Identify how deep learning can be made more effective. Basically, more use more hidden layers. In the deep learning, there is an input layer and then there is an output layer, and in between are various hidden layers. So the more hidden layers means the data set, the data which will be predicted will be more accurate. Okay. Describe the back propagation of error method in machine learning. Back propagation, when certain thing is in the machine learning, when the output is generated, and if that output is not correct, or if it is not very near to the expected outcome, then a back propagation is done. Means the output is again taken back, and then the values are the readjusted, and that is the back propagation. So let's see what points that the initial output are, these are compared to the expected output. Okay. And then weights are adjusted to minimize the difference between expected and actual. All right, so this is important. And then the calculus is used to find the gradient. Okay, this is one method which is used to calculate the error gradient in the. Okay, so the results are fed back to the neural network. Okay, the results are, they are taken back to the neural network, and this is the, then the weights of each neurons or the nodes are adjusted. They are adjusted as a result of the feedback, and the process repeats until results are more accurate. So this is all the process of the back propagation. Okay. An exception is an error that may cause a program to halt unexpectedly. Describe how program termination due to an exception can be avoided. Okay. So what we need to do is describe use an exception handling routine. ये आपके especially the questions related to the file handling, or which can avoid the program to crash, or also to avoid any illegal operation during the runtime, like division by a zero. So these kind of the things that can affect the execution of a program, they can be avoided by using an exception handling. Okay. So use an exception handling routine, and which is the try. This is how it is used. Two possible causes of exception. It can be a runtime error, all right, which is the coding error. Okay. And it can be the uh, input and output error, like file to open is not at specified location. So the file is not available at the specified location. All right. All right. Now the question number 11. Let's do this. The question number 11 is the table shows the assembly language instruction for processor that has one register accumulator. So the instructions are LDM, LDT, LDI, add, subtract, store. And this is the addresses 150, 300, and 420. Now in this question, write assembly language code using only the given instruction set 2, which is given in the table. Store the contents of the location 300 as labeled variable A. Store the contents of the location 420 as labeled variable B. Add the value stored in the address contained in variable B to the value contained in the variable A. Store the result in the variable answer. So let's do it. Now the first, that store the content of the location 300 as label. So what we will do, the assembly language instruction LDD load data directly, and address is 300. This will be loaded into the accumulator. And then when we write STOA, so it means the content of the accumulator, which was earlier stored by the LDD 300 of the address 300, is then moved to the location A. So this is the first bullet point. The second is store the content of the location 420, again LDD, and this time now the address is 420. And then we need to store this at the address B. All right. So first the content will be loaded into the accumulator, and then the accumulator's data will be stored at the address B. So second bullet point is also done. Now the third one, now you need to read this instruction very precisely. Add the value stored in the address contained in variable B. So the variable B has the address that refers to the value. So this is actually an indirect addressing. All right. So what we will write here, we'll write LDI. And LDI, and LDI is going to refer the location. The 420 is held at B. So it will first refer to the address B, and that address data will be loaded into the accumulator. And then what we need to do, to the value contained, add. So we need to add. Now we need to just write add A. So when we add A, it means now the content of the A will be added to the accumulator, which is loaded by the instruction LDIB. LDIB means load data indirectly from the content of the B. So B's content is actually an address which refers to another address, and then at that address, whatever the content is loaded into the A. All right. And store the result in variable B. So we'll write store and variable answer. Sorry. So this is how this assembly language code is written. Now the labels that we have used, we used A, we used B, and we used answer. And what is in the A? A has 300, and what is at the address 300? The 300 is 86. So A will have the content is 86. And what is in the B? B is 420. So B 420 is 150. All right. So at B we'll write. Okay. Now what comes in the answer? The B's location LDI. So we need to see this. LDI B means LDI is approaching the B's address. What is the B address? Is the 420. So first it is approaching the 420. So that is 150. Uh, 420 is 150. And what is that? So 150 is the further address. So LDI means it goes to 150 and it loads 26. So basically, what is loaded by the instruction LDB? What is loaded into the accumulator? It is 26. And what is add A? What is in the A? 86. So 26 plus 86 when it is added. So we can write it here. So what it becomes 2, 8, 8 and 2, 10, 11. So this is 112. Okay. So answer is 112. This is how this question is solved. I'm sure it is clear. Now the last question of this paper, and what is this? This is a stack. A stack has been implemented using pseudocode to store a maximum of 100 strings item using the global variable in the following table. And these are the identifier based off stack array and max. stack array and base and top is integer, stack array string, and the max is integer. The value of top is incremented each time. So this is all about the stack. So what we have to do, we need to complete the pseudocode for the procedure to add a data item into the stack, and push procedure is push. And what we are pushing uh, the data item, that is the new data. So we need to write, and this new data need to be string. How we come to know that this is a string? You can see that the stack array is actually of type string. So definitely the data which we'll put inside it must be string. Okay. Now if top is less than max minus 1, then we are going to increment the top. So top is top plus 1. And then once the top is incremented, and top is going to be used as an index for the array. So the array is stack array. And the top is index, and the data is going to be added over here. And if the top is not less than max minus 1, it is equal to the max, or it is, then what will happen? We are just going to send a message that that the value cannot be inserted. It is basically, it is an overflow. So we need to write an appropriate message that the stack is full, can't add a new data or item. So this is the message that we'll give. Okay. Now the question says write pseudocode to input a new data. Input a new data in and add it to the stack using push. So what we'll do, just simple. We need to input, and that is new data. And then we need to call push, and that new data is to be inserted in it. And the last question, explain the reason why stack is used. Last part, why stack is used when a recursive algorithm is executed. Because why stack is used? Stack basically three marks means we need to have at least 3 point. The stack stack stores data using last in first out principle. All right, this is one reason. Stack stores data using the LIFO principle. This is one. And each time a call recursive call happens, then what happens? It stores itself on stack, and when the base value reach its start unbind. So these are the reasons that the stack is used for the recursive algorithm. And this is all for your current paper. All right. Thanks for watching the videos. Thank you. Allah Hafiz.